Welcome to Exec Class Hub. My name is Antivirus. I'm your chemistry teacher. Okay, now we are starting with the introduction to organic chemistry. Introduction to organic chemistry. That's the topic for today. Introduction to organic chemistry. Now, let's start with the meaning of organic chemistry. Okay. Now, when you talk about organic chemistry deals with the study of organic compound. Organic what? Compound. This with the what? The study of organic what? Compounds. So it's very important for us to know what organic compound is. Now, let me discuss about a scientist known as Frederick Wohler. Frederick what? Wohler. In 1828. That proposed what is known as what? The vital force. Vital what? Force. Vital force law. The vital force law. Law states that organic compound can be obtained from the body of plants and animals. Yes. And we all know that plants and animals are organic compound. Plants and animals. So he believed that they believe that organic compound can be extracted from plants and animals until Frederick Wohler's synthesis of urea. Frederick Wohler was synthesis of what? Of urea. Urea can also be called the carbamide. This is a typical organic what? Compound. Organic what? Compound. Now, Frederick Wohler synthesized carbamide, which is also called the urea, from a typical inorganic compound called ammonium cyanate, which is what? Ammonium what? Cyanate. Ammonium cyanate is an inorganic compound. Ammonium cyanate is what? An inorganic compound. Why carbamide or urea? It's an organic what? Compound. So Frederick Wohler synthesized organic compound from inorganic compound. Do you understand? And we all believe that organic compound can be obtained from the bodies of plants and animals, which is not true until Frederick Wohler, a German chemist. A German what? Chemist. You understand? Although he studied medicine and surgery, but because of his love, he preferred chemistry to medicine and surgery, so he focused in chemistry. You understand? So he's a chemist and a medical doctor, but he based what? Dealing with what? Chemistry, because he had passion for chemistry. His name is Frederick Wohler, a German what? Chemist. So it's believed that organic compound can be obtained from the body of what? Plant and animal until Frederick Wohler synthesize an organic compound from inorganic compound. This is a compound NH2CO. Yeah, this is the what? Ammonium cyanate. So this ammonium cyanate, so he obtained what? NH2CO what? NH2. Now, this is said to be what now? Urea. So he obtained NH4CNO. This is what? The ammonium what? Ammonium cyanate. Ammonium cyanate is an inorganic compound. Inorganic what? Compound. What makes it to be inorganic compound is that it contains nitrogen, hydrogen, cyanide, and oxygen. What makes this to be organic compound? Organic compounds are compounds that contains carbon, hydrogen, and oxygen with some element like nitrogens and the halogen. So he obtained organic compound from inorganic compound known as ammonium cyanate. So his name is what? Frederick what? Euler. So that is known as what? Vital first law. Okay. Now let's proceed. So now what is organic compound? Organic compounds are what? Are compounds of carbon. Are compounds of what? Carbon, with the exception of metallic triazocarbonate, metallic what? Trioxocarbonates, carbide, and what? Oxides of oxygen, with the exception. So organic chemistry deals with the study of organic compounds such as carbon, hydrogen, and what? Oxygen. These are important. And little x. Whenever you see X in organic chemistry, it's talking about the what? The halogens. So the X can be what? It can be chloro, it can be what? The bromo, it can be what? The iodo. You understand? We call these halogens. You understand? They are called the what? The halogens. So in organic chemistry, this organic compound includes carbon, hydrogen, oxygen with little amount of the halogens. You understand? So organic chemistry, organic compound are compounds that contain carbon, hydrogen, and oxygen with a little quantity of halogens, and with the exception of metallic triazocarbonate, silicate, carbide, and oxide of carbon. So they are exception in what? In organic what? Chemistry. Now, I discussed about, so it's very important for you to know that organic compound can be obtained from inorganic compound. I discussed of the Frederick Euler synthesis of what? Of urea from ammonium cyanate. Now, let me give you the equations to represent that. So we have NH2, NH4, CO. This is what? Ammonium cyanate. Ammonium what? Cyanate. So we obtained NH2CO, NH2. These guys are urea or carbamides. Carbamides. Mind you, urea is an organic compound. Urea is made in the liver by a process called deamination, and it is excreted in the kidney. So urea is what? An organic what? Compound. So this is an inorganic compound. And when he eats it, he obtained what? An organic what? Compound. That is known as vital first law. So this equation represents the Frederick Euler synthesis of urea from ammonium cyanate. Don't forget, organic compound can also be obtained from inorganic compound. Well, it was believed that organic compound can only obtain from organic compound until Frederick Euler shocked the world. He synthesized a carbamide from what? Inorganic compound ammonium what? Cyanate. Okay. Now, in organic chemistry, carbon is very important what? Element. Just like in inorganic chemistry, silicon is very vital. So now we are going to look at the uniqueness of carbon. Now, before we move to uniqueness of carbon, I defined what? Organic compound. I said that compound that contain the constituent elements of carbon, hydrogen, oxygen with a little quantity of halogens, and with the exception of triazocarbonate, metallic carbide, and oxide of carbon. So we'll talk about that. So organic compound can be obtained from organic compound until Frederick Euler synthesis of what? Carbamide from ammonium or cyanate. He obtained a typical organic compound, carbamide, from an inorganic compound, cyanide. And I said he obtained this in 1828, and he was is what a German German chemist that proposed this law known as what law of vitalism. Law of what? Vitalism, or you can say law of what? Vital force. So he's the one that proposed it. Although there are some other scientists that also proposed the law. Okay, now let us now look at the uniqueness of carbon. Since carbon, uniqueness of carbon. Uniqueness of carbon. Why is carbon so unique in organic compound? The reason is that it has different features. Number one, carbon have the ability to catenate. We say catenation. Catenation. Yay. What is catenation? Catenation is what? The ability of carbon to link with one another, forming a straight chain, branch chain, or cyclic chain. That is said to be what? Catenation. Now, let me give you an example. Let's use propane, for example. Propane. Let's see how carbon is going to link with propane. We have carbon 1, 2, 3. This is propane. Yeah, this is said to be what? Catenation. Now, okay, it can also occur in this way. This is a straight chain. Straight what? Straight chain. Okay, it can also catenate like this. And this is a ring chain or cyclic chain. The cyclic what? Chain. Should be, do you understand? So that process in which carbon link together to form a straight chain or branch chain is called catenation. We all know that this is called propane, but it's called what? Cyclopropane. This one is called the normal propane. The normal what? Propane, or the straight chain propane. Now, I think I need to give another example. Let me use the butane. Butane, this is propane, and why this is called cyclopropane. Propane exists in straight chain, propane existing in what? In a cyclic chain. Okay? Let me give you other example. Let's use butane. Butane, okay. Butane. We have 1, 2, 3, 4. You understand? For carbon, this is for C4H what? 10. Okay, if you should complete it, this is what? 1 hydrogen, 2, 3, 4, 5, 6, 7, 8, 9, and 10. It's called the propane. But the hydrogen is not really necessary. We are going to talk about that in the next class. So this is called the what? The butane. So let's form another. This is also a branch form. The branch form. And this is what? Forming a straight what? A straight chain. The straight chain butane. And butane existing in a branch chain. And it can also exist in a closed ring chain. 4 carbon atom, 2 carbon, 3 and what? 4. This is a closed ring chain, which is called the cyclobutane. Can you see what catenation is? So ability, so what is catenation? Catenation is the ability of carbon to link with one another, forming straight chain, branch, or what now? Cyclic chain. So that is the meaning of catenation. So carbon has the ability to catenate. In group 4, carbon and silicon are the only element that can catenate. But catenation in carbon is more than the one of what? Of silicon. So it shows that catenation stops from silicon. Carbon, silicon. Catenation stops from silicon. Carbon can catenate. Silicon can also catenate partially. So that is what catenation is. So again, catenation is the ability of carbon to link with one another, forming a straight chain, branch chain, or the cyclic chain. That is one uniqueness. Number two, the second uniqueness is tetravalency of carbon. Tetravalency of carbon. What is tetravalency? Tetravalency of carbon is the ability of carbon having what? 4 valence electrons. That is what tetravalency is. Tetravalency is the ability of carbon to have 4 valence electrons. That is what tetravalency is. Now, let's check it. For example, in the ground state, carbon electronic configuration is 1s2, 2s2, and a 2p2. You understand? So let's count the valence electron. 2, 2, 2, 2 plus 2 plus 2. We have what? 6. Okay, so the atomic number of carbon is what? 6. Now let's look at the excited state. 1x, 2x, 2px, 2py, and 2pz. Why do we split p orbitals? Because the degenerated orbital in p is 3. So we have the total electron is 1 electron, 2, the 3 electrons, 4 electron, and the 5 electron. We have what now? The 6 electron. So look at this. 1, 2, 3, 4. So we have what? 4 what? Unpaired electron. 4 what? Unpaired electron. So that unpaired electron is the valency, which is 4. So that's why carbon undergo what is known as tetravalent. So carbon have the ability to form what? The 4 valence electron. Sorry, I need. So that is just what tetravalency is. One is unique. We discussed of the tetravalency. Ability of carbon having 4 valence electron. That is what tetravalency is. The valence electron of carbon is 4. Valence electron of carbon is 4. So that's why it's placed in group 4 in the periodic table, because its valence electron is 4. So because of its tetravalency, carbon form a complex compound in organic chemistry. Look at this. Look at what carbon is doing here. Although we know that this is called catenation. This catenation, ability of carbon to form a very long chain. Now let's count the number of carbon. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So this on decaying. So this is called catenation. But tetravalency, it's okay. Let's check carbon linking with some functional group here. See what happened here? See what happened here? Okay, let's assume we have COOH here. Yeah. So we can split it here to become, OH. Let's count the total number of valence electron. 1 electron, 2 electron, 3, and 4. So that is what is meant by tetravalency. Let me explain again. Let me use a short chain carbon. 1, 2, 3, 4, and 5. And we have O and OH here. So it's still the same thing as 1, 2, 3, 4, 5, OOH. So this is, let's count the number of carbon. 1 carbon, 2, 3, 4, 5, 6. Let's count this. 1, 2, 3, 4, 5, and 6. So now let's check the total number of valence electrons when carbon links with the functional group. This one is carbon 1, this is the single bond 1, 2, 3, and 4. So that is the reason why carbon is unique. Forming that process is called tetravalency. Okay, now let's check another example. Let's draw the structure of methane. CH4. Carbon atom is tetravalent. 1 carbon, 2 electron, 3, 4. How many hydrogen atoms is there? 4. Let's go. 1 hydrogen, 2, 3, and 4. So ability of carbon to form valence electron is called tetravalency. Okay. So that is the meaning of tetravalency of carbon. Carbon links with one another. It links with, in this place, carbon links with oxygen to form carbonic compound, carbonic group. Now, carbon links with OH here to form hydroxy group. Hydroxy group, which is called the alcohol group. This CO group is called carbonic group. I don't know. Are you getting it now? This is carbonic group, or it can also be called keto group. Keto group. The OH group is called hydroxy group from alcohol group. This is carbonic group. This is what OH group. So that is what tetravalency is talking about. That is example 2. Uniqueness. For 3. Carbon linked with electronegative elements such as hydrogen, nitrogen, oxygen, and the halogens. You know, I told you what this is. The halogens is talking about X. Chlorine, bromine, and iodine. They are the group 7 elements. So carbon is very unique to an extent that it links with some elements that are electronegative, although hydrogen is electropositive too. Okay, now let's check. Yeah, carbon links with hydrogen here. It can form methane gas. Sorry, this is methane. Can you say something? See, hydrogen is very unique. It can link with 3 atoms of hydrogen to form methyl. 4 atoms of hydrogen with carbon form methane, which is an alkane family. This one belongs to alkynes group. This one belongs to the alkanes, which is the paraffin. Do you understand? So what I'm trying to talk about is that carbon is unique. It has the ability to link with some elements like hydrogen, nitrogen, oxygen, and halogens. So carbon linking with hydrogen can form a methane gas. Carbon links with hydrogen, 3 atoms of hydrogen forms what? Methyl group. Now, for number 2, it links with nitrogen. Carbon links with nitrogen. Can you something? It links with what? Nitrogen, forming triple bonds. If carbon links with nitrogen, it forms cyanide. The cyanide, cyano, which is a cyanide. We call it what? Cyano. The cyano group. The cyano group. Like what happened here? NH4, CNO. So that's what really happened there. So let's check it out. Hydrogen links with, how many hydrogen atoms do you have here? Can you see something? Linking with cyanide. Are you there? So this is what really happens here. So now linking with what? Oxygen. If links with oxygen, it's forming CO. This CO is said to be carbon monoxide. Carbon what? Monoxide. If it links with CO2, that's carbon what? Carbon 4 oxide. So it's forming an oxide of carbon. Although whenever you see CO in organic chemistry, it's not called carbon monoxide, it's called carbonyl. Carbonyl group. Carbonyl groups. And or you can also call it the keto what? Keto groups. So let me repeat myself again. We are talking about the uniqueness of carbon. Carbon can link with electronegative elements, linking with an hydrogen forming methane, methyl, linked with ammonia, linking with nitrogen, it forms cyano group. Linking with oxygen, it forms keto group. And CO can be carbon monoxide, carbon monoxide, CO2 can be what? Carbon dioxide. That's one uniqueness of carbon. So for linking with the halides, halogen, sorry, if it links with halogens, it's going to form what is called the halides. The halides. The halides, like, if it links with, this is chloro. Chloro depends on the number of carbon. If it is one carbon, is what? Chloromethane. If it links with two carbon, CCl2, it will be dichloromethane. They are the halides. If it links with bromine, it's going to be what? Bromoalkane. But if it is only one carbon that links with bromine, it's called bromomethane. If there are two bromine, that's when you're going to have a dibromomethane. Why are we saying methane? Methane has only one carbon. Do you understand? So that is the reason why carbon is very what? Unique. Okay. So now I want to, let me clean the board and proceed. Now the last uniqueness is carbon forming what? Ability of carbon to form a single bond, double bond, and the triple bonds. Triple what? Bonds. Carbons form single bond, double bond, and triple bonds. In this place, carbon can link with this. This is a single bond. And if carbon has a single bond, it is called, belongs to the alkenes. Carbon forming a double bond here. This is a double bond, belongs to what now? The alkenes. Whenever you see double bond, it's called hene. Whenever you see single bond, it's called hene. The suffix "ane". Alkane. Double bond "ane". Alkane. If it has a triple bond here, it's alkyne, which is what? Ine. So that is the reason why carbon is unique. A single bond, double bond, and the triple bonds. The triple what? Bonds. So if carbon atom hold a single bond, is alkane. If carbon atoms hold double bond, is said to be alkanes, which is ene. If carbon atoms hold triple bond, is ine, which is the alkynes. So that is the uniqueness of carbon. Ability of carbon to form single bond, double bond, and the triple bond. Okay. Now let's proceed. Now let's look at the properties of organic compound. Properties of organic compound. You know, we need to know the properties of organic compound because we have an inorganic compound also. Number one is that Number one, they are covalent compound. That is, the bond that exists in them is what? In them is covalent what? Bond. Take note. All organic compounds are covalent compound. The bond that exists in organic compound is what? A covalent bond. Due to the covalent bonds, due to the covalent nature, they are non what? Conductor of what? Electricity. Non-conductor of what? Electricity. Hence, they are non-electrolyte. Non-electrolyte. They cannot conduct electricity because they don't have unlike charge of electrons. So they are covalent compound. The bonds that exist in them is a covalent bond, and that's due to the covalent nature. They are non-conductor of electricity, and they are non-electrolyte. Non-what? Electrolyte. Non-electrolyte is in that they cannot conduct electricity in molten states or in solution. That's number one. Number two, they are what? Insoluble in polar solvent, e.g. water. So you cannot expect organic compound to dissolve in water. They're insoluble in water. For example now, kerosene is an hydrocarbon. Let's use fatty acids. A fatty acid is like, let's use oleic acid. Oleic acid, an example from olive oil. Oleic acid from olive oil and dissolve oleic acid inside water. You observe that oleic acid will not dissolve in water. It shows that oleic acid is insoluble in water. Are you there? And it shows that oleic acid is what? Non-polar. We should know that oleic acid is a fatty acid and it's called unsaturated fatty acids. It's classified into what? The unsaturated what? Fatty acid, and it's gotten from plants. So almost all plants fatty acids are what? Unsaturated, and they are very good. Unlike saturated fatty acid, like stearic acid. The stearic acid, we have the palmitic acid. All these are examples of organic compounds. They cannot dissolve in water, so they are insoluble in water. Okay, number two, they are soluble in non-polar solvent. E.g. ether, benzene, toluene, etc. Yes, you can dissolve that stearic acid, that oleic acid, palmitic acid, capric acid, or all fat and oil. You can dissolve them inside. You can dissolve them inside non-polar solvent. That shows that they are soluble in non-polar solvent because non-polar plus non-polar dissolve. You can dissolve kerosene inside petrol. Kerosene is non-polar. Petrol is non-polar. So they dissolve. So polar plus polar dissolve. For example, we can dissolve water inside ethanol. We all know what ethanol is now. Ogogoro. We can dissolve ethanol inside water. It will dissolve. But ethanol is organic compound now. What makes ethanol to dissolve in water? The reason is that ethanol has the formula of what? C2H5OH. It can also be called ethyl alcohol. The reason is that it's so simple. Ethanol has a functional group called hydroxy group. Hydroxy what? Hydroxy group, which form an hydrogen bond with water. So it is because of the functional group which is the hydroxy group, links with what? The hydrogen found in water to form an hydrogen bonding. So that's what brings about the solubility of ethanol with water. So that's the reason why ethanol can dissolve in water. We can dissolve ogogoro inside water because ogogoro, it's an organic compound, but what makes it to dissolve in water is that it has an electronegative element, oxygen. You understand? Or it has a functional group, hydroxy group, that links with hydrogen found in water to form a bonding called the hydrogen bonding. So that is why some organic compound dissolves in water. So they are insoluble in polar solvents, e.g. fatty acid, oleic acid cannot dissolve in water. That shows they are non-polar. So they are soluble in non-polar solvent like ether, benzene, toluene. They can dissolve in it. So petrol can dissolve in ether, benzene can dissolve in ether, kerosene can dissolve in benzene, but water cannot dissolve in benzene. The reason is that water is polar, benzene is non-polar. Toluene is non-polar, benzene is non-polar, ether is non-polar. You understand? So because they are non-polar, they cannot dissolve in water. Number 3, organic reactions are very slow. They are very slow. They need what? They need catalysts. Catalysts to what? To speed the reaction. So reaction involving organic chemistry, organic compounds are very slow. So they need a catalyst to speed up the reaction. So you know what catalyst is? Catalyst is what speed up a chemical reaction. So let's look at a reaction, a simple organic reaction. Let's look at addition reaction of unsaturated hydrocarbon. This guy is 18 plus, if you react with an hydrogen gas, you will get C2H6. Are you getting it? Yeah, this guy is what? 18. This guy is 18 is what? An unsaturated what? Hydrocarbon. Why this guy is what? Saturated. This reaction is extremely what? Slow. For the reaction to be fast, you put a catalyst in it. You can put a catalyst like nickel catalyst. Nickel catalyst will speed the reaction. You understand? So this reaction is called hydrogenation reaction or addition reaction. So all reaction involving organic chemistry, organic compound are very slow. Okay. So it is catalysts that speed up their reaction. Let me give you another reactions that involve. Look at this reaction. Arrow, and what? Arrow, you go get Rico, you go get water. Yay! What's this reaction? This reaction is called esterification. This guy is an alcohol plus what? Carboxylic acid. You go get ester and water straight up. This reaction is called esterification. This reaction will be very slow except you put a catalyst in it. The catalyst we put in this is called H2 tetraoxosulfate acid, which you call the sulfuric acid. If you don't put this catalyst, the reaction will be what? Will be slow. Look at another reaction. This reaction is an inorganic reaction, which everybody are familiar with, and it is called neutralization reaction. Acid come here, base come here. You go get what? Salt plus what? Water, straight up. This reaction is very fast because the compound involving the reactions are inorganic what? Compound. If you look at H2SO4 plus what now? Sodium hydroxide. What do you go get? You go get sodium what? Sulfate, which is a salt, plus what? Water. Now, this reaction is what? Neutralization reaction. We don't need any catalyst to speed up the reaction because reaction involving inorganic reaction are very fast. So if it is organic reactions, they are what? Very what? Slow. So catalyst is involved to speed up their reaction. Okay, let's proceed. The next one is Organic compounds are highly inflammable. Highly what? Inflammable. That is, they bond exothermically. Exo what? Thermically. In what? In the presence of what? Of air. You observe that they always say, this fuel, this tank is highly inflammable. Inflammable means it catch fire easily. So most organic compounds are inflammable. That is, when you expose them to air, fire, it will what? Burn and liberate large amount of it. So organic compounds are highly inflammable. Petrol is inflammable. Plastic is inflammable. So organic compounds are highly what? Inflammable. So another properties is that organic, have I talked about that? Have I said they are non-conductor of heat and electricity? Okay, so these are the properties of organic what? Compounds. So now let's move to the next subtopic, which is very important. Our next topic is alkynes group, the functional group, and homologous series. Homologous what? Series. Now, we need to know what, before we know what homologous series is, we must have the idea of alkynes group and what? The functional group. Now, what's an alkynes group first? Now, alkynes groups can be what? Can be formed from alkane. Alkynes group can be formed from alkane with the loss or removal of one hydrogen atoms. One hydrogen what? Atoms. So that's what alkynes group is. Alkynes group can be obtained from alkane by the loss or the removal of one hydrogen atom. It has the general molecular formula of CnH2n plus 1. This is the general formula of alkynes group and it represents capital letter R. So alkynes group represents capital letter R. If you see R in organic chemistry, it's representing what? Alkynes group. Note, the R, which is the alkynes group, determines the physical properties. Determines what? The physical properties of the organic compound. It determines what? The physical properties of what? Organic compound. You can say it determines the physical properties of what? The homologous series. So what determines the physical properties of the homologous series? Alkynes group. And it represents capital letter what? R. Now, so what is an alkynes group? Alkynes group are formed from the loss of hydrogen atom from one hydrogen atom from methane from alkanes. So alkane have this formula CnH2n plus 2. Alkenes have this formula CnH2n plus 1. This is alkane. And why this is what? Alkynes group. So now let's check something. Let's check very well. Look at alkanes family. Let's look at the formula of alkanes here. Let's look at this guy, alkyls. And let's look at the formula here. And let's go back and check something. Okay. Let's look at the carbon one. Number of carbon. 1, 2, 3, 4. Okay. Mates, carbon 1. X, carbon 2. Probe, carbon 3. Boot, carbon 4. H6. H6, 8, H10. Now, so this is CH4. This is C2H6. C3H8. C4H10. So, what's the name? What's the name of one carbon? First carbon is methane. Hane. From the parent, hane. Ethane. We have what? The propane. And we have what? The butane. Hane. Oh yeah, guy, remove one hydrogen atom here. What you go get? You have CH what? 3. Remove one hydrogen atom here. What you go get? C2H what? 5. Remove one hydrogen atom. You go get what? C3H what? 7. Remove one hydrogen here. You go get what? C4H what? 9. And what's the name of the parent? Ew. So it's not going to name A again. It's going to be what? Met. One carbon is what? Met. So it's going to be what? Methyl. You remember 2 carbon is et. It will be what? Ethyl. 3 carbon is what? But. Sorry, pro. It's going to be what? Propyl. 4 carbon is what? But. It's going to be what? Butyl. So we have, can you see how alkane is gotten from? Alkyl is gotten from alkane. It's gotten from alkane by the laws of the removal of one hydrogen atoms. I also say alkyls group represents capital letter R, and it has the general molecular formula of CnH+1, and it determines the physical properties of the homologous series. So that's just what we need to know. Don't forget, alkyls group determines the physical properties of homologous series. Okay? Now let's proceed. Now, let's proceed now. Let's move to the functional group. You know, the topics is alkyls group and functional group. Alkyls group and functional group. Without functional group, alkyls group cannot exist. Without alkyls group, functional group cannot exist. So they are together. So if you have them, if you have alkyls group, it must bind with the functional group. If these guys come together, you are going to get what is called the what? Homologous series. So the combination of the alkyls group and function. So alkyls group and functional group forms the homologous series. So they are dependent with each other to form what? An homologous series. Although I'm here to tell you the meaning of what? Homologous series. So let me give you an example of alkyls group. We have CH3 methyl, C2H5, ethyl, propyl. That's alkyls group, but it remains functional group. So let me define functional group for you. Functional group, it's a bond, ions, or radicals. Ions or radicals common to homologous series. Common to homologous series that determines the chemical properties of the series. That determines what now? The chemical properties of the series. So functional groups they are what now? They are bonds, ions, radicals, common to homologous series, and determines what? The chemical properties. Don't forget in your life, functional group determines chemical properties of the homologous series. But alkenes group determines what? The physical properties of the homologous series. Take note of that. Okay? So now let's now look at examples of the functional group. If you have, let me give you a few. It's not must I give everything. By the time you get to homologous series, you see a lot of functional group. You have this. This is called chloro. It must have a bond here. Okay, I think it's there. Sorry. So it's having a bond here. Yeah, this is bromo. This is iodo. Understand? So this is bromo. Sorry, fluoro. That they are all called halogens. They are called halogens. So we have, whenever you see OH, it is called alcohol. Or all. That's the name. Whenever I see COOH, it is called carboxyl group, which is called oic acid or alkanoic acid, or it can also be called the carboxylic acid. So this is called carboxyl radicals. You understand? So we have CHO. Whenever I see CHO, it's called al. You understand? The parent name is alkanamide. Sorry, alkanal, or it's the aldehydes. We have CO. I told you earlier, it's called keto, or keto, or So we have CONH2. It's called amido, or amide, or alkanamide. Sorry, amido, or alkalamide. If you have CHCN, it's called cyano. If you have NH2, it's called amino. If this exists, called wait. The OH is from ester, or I can wait. You have this. Okay, this is alkanoids, amino, cyano, amido, keto. From aldehydes, oic from alkanoic acid or carboxylic acid. Okay, we have oxy linkage from ether. We have alkyl oxy alkane. That's the parent name, or ether. So the formula is ROR. The oxygen linkage. So the oxygen is the functional group linking with the two alkenes group. So these are examples of functional group. We have more examples. So when we are dealing with what homologous series, I'll show you more example of functional group. So let's proceed. Now let us form homologous series. Let's form it. Let us form, I said functional group plus alkenes group give us homologous series. Okay, but it's better we write alkenes group first. So we form it like that. Alkenes group plus functional group will give us homologous what? Series. Okay, let's go. Methyl CH3, ethyl C2H5. Now, let's add a functional group from alcohol. OH is all. OH, it's all. Add it together. You have CH3, OH. It has formed a name. Let's add this together. C2H5OH. Let's go back. What did I call methyl? This is ethyl. What's the parent name? R is their parent name. What is alcohol? Alkynes. Add the functional group. It has formed what? An homologous series called the alkanol. Alkanol. So, what is this guy? How many carbon atom being here? 1. So it's what? Methanol. How many carbon atom is here? 2. So this will be what? Ethyl or ethyl alcohol or ethanol. So can you see that now? Okay, it's very important. You know this. Okay, let me give you another example. CH3, what's it called again? Methyl. C2H5, what's it called again? Ethyl. Let us add carboxylic acid, carboxylic group radicals. See something? Wow. Plus another was COH. Something has. Okay, now let us form an homologous series here. Let's add it together. You have CH3. Add the functional groups. Wow, wonderful. Add this together. C2H5, COOH. Wow. What is the name of this compound? Let's go back. CH3, C2H5. They represent what is called alkynes group. Don't forget. This is their parent name. This is methyl and this is ethyl. Add the functional group. Wow. They form a functional group called what? Carboxylic group. Carbo what? Xylic what? Acid. Or alka what? Alkanoic what? Acid. Okay, what's the name of the compound? Look at how many carbon do you have here? 2. Shebi? How many carbon atom do you have here? 1. It's very wrong. Whenever you are asked to count, whenever you are asked to name organic compound, you start counting the carbon that links with the functional group. The carbon atoms that form the functional group will be counted. So let's count this. 1 carbon and 2 carbon. Let's count this. 1, 2, 3. So 2 carbon atom is eth. So the compound is called ethanoic acid. 3 carbon atom is prop. So the name of the compound is what? Propanoic acid.